This is the VCM 600 vacuum evaporator. VCM 600 is a family of vacuum evaporators according to the configuration of its system. This one is a more complicated system because it incorporates the vacuum control here. This is the manometer, this is the turbo pump controller, the thickness monitor installed, two independent driven power sources with the current control knobs, two independent driven shutters, the substrate rotation facility from 0 to 40 RPMs, and this is the vent valve. To operate the unit, first we turn the power on. We observe that the thickness monitor does not operate, and the red light here that is the water is light on. The thickness monitor operates only when the appropriate pressure of the water is connected to the system in order to protect the crystal head from overheating. Now we have here the protection guard. Moving the protection guard, we are going to open the vacuum sampler. Here we moving the glass bell jar. And now we have here the base plate with all the attachments. We observe that we have two shutters over each thermal source. We have the thickness monitor, here crystal head. We have the substrate holder and the substrate rotation mechanism. To work with loading the filaments or the bolts, we must to open the shutters, activating the knobs. Now we have the two shutters open, and we have a bolt, a tungsten bolt, and a tungsten filament. We can place here the material for evaporation or the metal pieces here. When we load these two sources, we are ready to evaporation. These two are the filament protectors, are also protecting the cross-contamination between the two materials. Here we have the substrate holder where we can place our substrate. The substrate holder offers the facility of rotation. Here in the front face of the unit, we have the substrate rotation control with variable speed. This helps us to have the better uniformity in the system. VCM offers a very good uniformity on substrate, on coatings, more than 95%, due to the very well designed distance and things inside the vacuum sampler. Now we have loaded our samples. We close the shutters. We place the bell jar in the correct position. We place the protection guard in the correct position. And we are ready to start evaporation by activating the vacuum system. For this purpose, we activate the RAF pump by turning this switch. Soon, we will observe the pressure that goes to lower values. We observe the vacuum level in the sample. As soon as the vacuum level falls below 10 millibar, we can activate the turbo pump. Now we have on the display the actual speed of the turbo pump and the acceleration of the motor. We will observe here how fast the turbo pumps drive the system in lower vacuum levels. As soon as we go below a certain level, the red light in the evaporation sashes will go light up here. Now we have an indication that we have a safe vacuum level to do evaporation. Naturally, the system can reach very low levels of vacuum. Here, after less than 1 minute, we're going down to 10 to minus 5. After a short period of time, we can very fast reach 10 to minus 5 millibar, and after a while, let's say 10 or 15 minutes, we can go down to 10 to minus 6 millibar. As the red line is on, we can drive with current the thermal sashes in the system. Activating the current control knob, we control the intensity of the current that passes through each source. Here we have the current that passes through source 1. It's a filament, and we have 50 or 60 amps, and here we have a bolt that needs much more current intensity, like 150 amps or more. The value of the current intensity controls the temperature of the source. As soon as the temperature reaches the desired value that we have, we can start deposition by opening the shutter. Now we have deposition in our sample, and here we will observe the thickness of the monitor, the thickness of the film that is produced on our sample. As soon as the thickness reaches the desired level, we close the shutter, the deposition stops, and we minimize the current in the source. Of course, we can use the substrate rotation facility to improve the quality of the thin film that we produce on our sample. The thickness on our sample is measured through the crystal, the quartz crystal head inside the sample. Finishing the deposition, we can wait for the turbo pump to stop. We use two different sources, independent driven, for allow us to evaporate two different type of materials without breaking the vacuum. For example, we have, it's very easy for us to have in thermal source number 1 chromium and in thermal source number 2 gold. We use chromium to produce a very thin, thick level, a very thin film that has a very good adhesion on the substrate. Then we use gold to produce the desired thin film. Finishing evaporation, we turn the turbo off. Here we are less than 2 minutes and we have 2.9 10 to minus 5 millibars in less than 2 minutes. The system is extremely fast. We turn the turbo pump off and using the variable leak vent valve, we can start venting the system in a way that the deceleration value presented on the turbo pump controller is not more than 300. This is a big number. It's not more than 300 RPMs per second. This way we can vent the system faster. It is recommended to use as a venting gas nitrogen, dry nitrogen, as this protects all the environment of the vacuum sample. After finishing and stopping the turbo pump, we can still evacuate the system until we reach the atmospheric pressure. Then we stop the rough pump and after a while we open the sample. Now we have our sample with the thin film on it.